Let's implement another pretty common feature on web pages, which is that the navigation bar becomes attached to the top of the page after we scroll to a certain point. And this is called a sticky navigation, and so let's build one for our site. So the effect that I'm talking about is this one. So as we scroll down, once we then reach a certain point, the menu bar here becomes attached to the top of the page. And once again, I'm sure that you have seen this in many pages that you visit. Now let's just check out the HTML here just to see how this works. So we make this navigation sticky basically by adding this sticky class whenever we reach a certain position. And so this sticky class, as you can see here on the right side, all it does is to set the position to fixed, and it also changes the background color to this transparent. So you see that we can actually see through this navigation a little bit, which gives it a really cool effect. Okay. So sticky navigation. And to implement this, we're going to use the scroll event for now. So there's actually a better way of what we're going to do in this video, but let's start by working with the scroll event now, because sometimes that's good to know as well. So the scroll event is available on window. All right, so not document, but really window.add-event-listener and then scroll. Okay, so this event will be fired off each time that we scroll on our page. Okay, and let's start by taking a look actually at the event, just so you see that it actually fires each time that I'm scrolling. So I just scrolled this little bit and it already created all of these events. So it fired all these times. So the scroll event is not really efficient and usually it should be avoided. But again, for now, let's use that. And now let's start by getting our current scroll position. So let's use window.scroll y, just as we learned before. And so this scroll position here is really on the window object and not at the event. So in the scroll event, this event object here is actually pretty useless. We don't even need it here. Okay, so let's just reload here. And so as we scroll, you see that each time the event is fired, we get the current scroll position. And remember that this is the position basically from the point in the viewport, so this point here, to the very top of the page. And that's why in the beginning we start at 0, because now the visible part of the site is exactly also at the top of the page. Okay, so remember, to make the navigation sticky, we will add that sticky class that I showed you earlier. But now the question is, when exactly should the navigation actually become sticky? Well, it should happen here as soon as we reach the first section. So basically as soon as we reach this position. So this line here marks the beginning of the first section. And so when we reach this position, we want to make the navigation sticky. Now, of course, we're not gonna like hard code the value here. So I could take like 565, but that doesn't work because the size of this element that comes before is actually dependent on the viewport size. So if I do this, then you see that the first section starts way earlier, so like at 300. And so we cannot hardcode the value, and therefore we need to calculate it dynamically. So how do we do that? Well, remember that we can determine the position actually of this first section. So let's do that. And I think I already have it selected up here. Yeah, so section 1, which is this one. So we need to do this outside actually of this event handler. So that section 1 dot get bounding client rect, remember. And so let's call this initial coordinates. So just coords. And take a look at it. And so now we get this current top value here. Where is it? Ah, right here. So we get the current top value of this section. And so we can now work with that. And it's even better if we do this when scrolled to the top, because then basically this top position here is all the way from the top of the page all the way here. So all the way to the beginning of that first section. Okay, and so let's now use this value to add our sticky class. So we can say that whenever the window.scroll position in y is greater than the initial coordinates at the top, then we want to add this sticky class, right? And if not, then we want to remove it. So I can use nav here because I already selected it in the previous lecture. So nav is of course this entire navigation bar that we also worked with in the previous lecture. So remove here. And here indeed we need a new line. And so now that works. And so let's check this here. And wait for it. And indeed, now it's here. So now the sticky class was added because we reached the position in the page which is greater than the distance of this first section from the top. All right. So this works just fine now, but as I mentioned before, this is pretty bad for performance. So using the scroll event for performing a certain action at a certain position of the page is really not the way to go. And again, that's because the scroll event here fires all the time, no matter how small the change is here in the scroll. And so that makes for a pretty bad performance, and especially on mobile. Like on a modern computer, of course, you're not going to notice anything. But if you're using this page maybe on an older smartphone, then it's not going to be so nice. All right. And so in the next video, we're going to look at a better and way more efficient tool, which is the Intersection Observer API. All right, so let's now implement the same sticky navigation that we implemented in the last video, but this time using the new Intersection Observer API. But what actually is the Intersection Observer API, and why is it so helpful? Well, this API allows our code to basically observe changes to the way that a certain target element intersects another element, or the way it intersects the viewport. And so from this definition alone, I think you can see that this will actually be useful in implementing our sticky navigation. But let's actually start this video by learning how the Intersection Observer API actually works, but without our sticky navigation, because at the beginning, this can seem a bit intimidating and confusing. Okay, so to use the Intersection Observer API, we need to start by creating a new Intersection Observer. So that's Intersection Observer, just like this. And then here we will have to pass in a callback function and an object of options. But let's leave that for a bit later. Okay. So let's first store the result of calling this function into a new variable. So let's simply call it the observer. And so now we have to use this observer to basically observe a certain target. So observer, and then the method we call on that is observe. And then here the target element. And this one will be section 1. And so this is an element that we already selected before. So this will make a bit more sense once we actually create the callback and the options here. And let's start by the options. So const, let's call it the observer options. So ops options. So this is going to be an object, and we can also already create the callback function. Let's simply call this observer callback. All right. And of course, we could have created these right here, because this is where we will now pass them in. So first the callback, and second the options. Okay. And so once again, we could have written the function and the object directly in here, but I think it's a bit cleaner to have them separately. So let's now start with the options here. And so this object needs first a root property. And this root is the element that the target is intersecting. So again, this here is the target, and the root element will be the element that we want our target element to intersect. And again, this will all make more sense once you see this in action. So we could now here select an element, or as an alternative, we can write null, and then we will be able to observe our target element intersecting the entire viewport. All right. So basically this entire rectangle here, which shows the current portion of the page. Okay. And then second, we can define a threshold. And this is basically the percentage of intersection at which the observer callback will be called. So this callback here. So again, that's very confusing. Let's just set it to 10%, which is 0.1. And then when we have this callback function here also created, then we will see what actually happens here in practice. All right. So this callback function here will get called each time that the observed element, so our target element here, is intersecting the root element at the threshold that we defined. Okay, so take note of this, because this is actually a bit hard to figure out from reading the documentation. And so it's a good idea to keep notes of what I'm saying here. So in the current example, whenever the first section, so our target here, is intersecting the viewport at 10%, so the viewport because that's the root, and 10% because that's the threshold. So whenever that happens, then this function here will get called, and that's no matter if we are scrolling up or down. All right. And this function will get called with two arguments. And so we can specify them here. And that's the entries and the observer object itself. All right. So this object here basically will also get passed into the callback function. All right. Now in this case, we're only interested in the entries, but sometimes using the observer is also useful. Now we can have actually multiple thresholds. So here we can have an array, and I will do that in a minute. And so these entries here are actually an array of the threshold entries. Okay, and so in this case, again, there's only one element there, but let's create a more general function already, which basically loops over these entries so that we can take a look at all of them. And so let's just do that. So basically simply log them to the console, and that will already be good enough for us to take a look at how this all works. So entry, and so you see I'm using an arrow function here, but of course any other function would work just the same. Let's give it a save now, and you see that already we get an intersection observer entry. And so that is this entry here. And so this is not really interesting yet, because this is just the first one that we got, and we see that the ratio here is at 0, but let's see in a second what that actually means. So I will start scrolling here, and you see that now we actually got our first real entry here, which appeared here because our target element came into the viewport. So our target element is this whole H1 that's down here, and so you see that it started intersecting the viewport. Okay, and so our observer is observing that. And so now here you see that the intersection ratio at the time that this callback here was called, so this one here, was at 0.10 and then this. And so that's exactly the 10% threshold that we defined over here. All right. We also get this is intersecting property, which in this case is true. And that is because indeed our target, so again, this whole section here is now intersecting the viewport. And we are looking for the viewport, remember, because we set the root to null. All right. So we also get the target itself here and a couple of other stuff, but the intersection ratio is actually the most interesting one, and also the is intersecting here. Okay, so let's scroll down a little bit more, and let's close this actually, and let's scroll up again. And so again, we get a new entry here. And so again, it should be close to 10%, but now it happened as we were moving up, right? And so again, it was at 10%, but now it is no longer intersecting, okay? And it's not intersecting because the threshold is at 10. And so now less than 10% basically of our target here are inside of the root, so inside of the viewport. All right? And so you can start to see why this is more efficient. So it's because we only get this kind of event here in the situation that we're actually interested in. So in this case, that's this threshold of 10%. Okay, and as we keep scrolling here, now it will come back again, and now it is again intersecting. Let's keep scrolling, and all of this here is section 1, and now we got another one. So let's see. And so now it is back to not intersecting, and because now we no longer have 10% visible. Okay, so you can think of this threshold here at the percentage that we want to have visible in our root. So in our viewport in this case. And so right now we are back to having less than 10%. And so it is no longer intersecting here. And again, if we scroll up a little bit more, then we get another event here because now we are back to having 10% intersection ratio. Okay? So this is the very fundamentals of how the Intersection Observer API works. And I confess that it is a bit confusing, and it took me quite some time to figure all of this out. And so probably the best idea is for you to stop this video now and explore this a little bit on your own. So you can use different threshold values and maybe use different targets here. You can even use different roots. And so it would be a good idea to experiment a little bit more with this. Now what I'm going to do here is to now specify an array. So to specify different thresholds, and one of them is going to be 0 and the other one 0.2. So that's 20%. So 0% here means that basically our callback will trigger each time that the target element moves completely out of the view. And also as soon as it enters the view. Okay? And so that's because the callback function will be called when the threshold is passed, when moving into the view, and when moving out of the view. And this is really important to remember here. On the other hand, if we specified 1 here, like this, then that means that the callback will only be called when 100% of the target is actually visible in the viewport. So in the case of this section 1, that would be impossible because the section itself is already bigger than the viewport. But let's now experiment with 0 here. And so right away, we again get this event here. And you see that the intersection ratio is exactly at 0, but it is already intersecting. And so it's because basically the threshold here was already passed. All right. So I think another one happened there. Let's just reload. Oh, and that was probably from our 20%. Yeah, so you see, this is the 20 threshold, the one that we set here now. And so this one now happened a little bit later than before, because before it was happening at 10%, but now only at 20. So that's a bit later. Let's just clear this and keep scrolling. And so now this section is almost scrolling out of view. And you see, we now get this 20% here. So a bit less than 20%. And as we keep scrolling, then as this line hits here the top of the viewport, we should get another one, which is when this 0 here is again reached. So let's try that. And indeed, here it is. So we are back to intersection ratio at 0, and the element is no longer visible. All right. So this is how the intersection observer API works. And let's now quickly use this in order to implement our sticky navigation. Because at this point, I'm sure that you can already imagine how this can be very useful for implementing this in an easy way. So let's think about this. When do we want our navigation to become sticky? Well, we want that to be happen essentially when the header moves completely out of view. So basically all of this part here, which is the header, when we can no longer see it, that's when we want then to display the navigation. Okay, and so this time we are going to observe the header element. So let's start by selecting that. And it is an element with the class of header. All right, let's actually get rid of this part here. Okay, and now let's create our observer. So this time I'm calling it the header observer, just so we know exactly what is being observed. So new intersection observer, and then I'm going to pass in the arguments later, and then I will use the header observer to observe the header. Okay, so this all kinds of sounds like normal English sentences if we read it like this, right? So here we again need a callback function. So let's just call this sticky nav, actually, and then again the options. Now this time I will just create the options object right here. All right. And so the root will once again be null because we are again interested in the entire viewport, and then the threshold. So I said that we are interested in showing the sticky navigation as soon as this header scrolls completely out of view. So what threshold does that mean? Well, that's just 0, right? So when 0% of the header here is visible, then we want something to happen. Okay, and now let's define this function here. And here we will have exactly the functionality that we want to happen. So to add and to remove the sticky class. So this function gets the entries, and this time I'm not going to specify the observer because in this case we don't need it. Also, there is only one threshold here, so I don't need to loop over the entries. We can simply get the first one, and let's actually use the structuring to get the first element, so entry, to get the first element out of entries. And remember that this is the same as writing entries 0, right? So let's just start by taking a look at this entry just to see if it works. And here, one more time, we already get something. So I'm not sure why that is actually, because this has nothing to do with our threshold. All right, but let's just wait for the next one. And so it should be appearing soon because our target, so this header, is almost moving out of the view. And indeed, here it is. So intersection ratio is 0 and it is no longer intersecting. And so now let's actually create the logic of adding and removing the classes. So basically what we want to do is to first add it here. And so let's start with that. But you see that now it actually already applied this class. And that's because right now our target element is intersecting the root, so the viewport. All right, so we will use that in a second. Let's just see what happens next. So here we will now get our next one, right? And so now it is no longer intersecting. So intersection ratio 0, but no longer intersecting. And so this is actually the condition that we are interested in, right? So only when the header is not intersecting the viewport is when we want to add that sticky class. Because watch what happens when we move back up. So right now, you see we got this new entry here. And so in this case, it is again intersecting. And in this case, where we are scrolling up is when we actually want to remove that sticky class, right? So we are entering the header again. And so that's the point in time where we want the sticky class to be gone. And so now we can use this intersecting property to do exactly that. So we can say that if the entry dot is intersecting is false, basically, then do this, right? So again, when the target is not intersecting the root, then we want the sticky class to be applied. And else, we want to remove it. So let's reload. And now, indeed, the sticky class is no longer there. Okay, and now watch what happens as this line reaches the top there. Then, yeah, here it is. So there is our sticky navigation. So that's great. And indeed, it is because it is now no longer intersecting. And so now the final test is when we move back up, then it is gone. And so as we scroll around this point, it will basically add and remove the class according to the scrolling direction. Now we're actually not really done yet because I want to make this a little bit different or a bit better. So let me show you the demo here. So just to make sure, I'm going to reload it here. Never mind this effect you just saw here, but watch when the navigation comes in here. So you see when that happens, it's basically when the distance between the start of the section and the viewport here is just the same as the navigation. You see that? And so like this, the navigation doesn't overlap this section here right in the beginning. So here the navigation comes exactly before the first section starts. And so let's implement it here as well. And thankfully, that's pretty easy to do. And we can do it by specifying another property here, which is the root margin. Okay, and this root margin here, for example 90, is a box of 90 pixels that will be applied outside of our target element, so of our header here. Okay, and so now it is as if the header did not stop right here, but instead out here. All right, so as if the header went all the way here. Now we actually want the header to basically stop here. And so that's minus 90. Okay, and here we then need to specify also the unit, which has got to be pixels. So unfortunately, percentage does not work, and also rem does not work. So it has to be pixels. And so that's why I'm using 90 pixels here. And 90 is the height of the navigation. And so let's test this here again. So let's see. And so let's wait for it. And did you see that? Indeed, now the navigation appeared exactly 90 pixels before the threshold was actually reached. So you see, now we get the event here even later. And all the data here is still the same. This is simply a visual margin that gets applied. So you can play around with this as well, with the difference between a positive and a negative margin to figure out really how this works. Because this root margin here is very important to specify correctly, as we need it in many situations. Now, just as one final detail, let's actually calculate this height here dynamically. And for that, we can use again the getBoundingClient rect function. Because, for example, if you have a responsive site, then probably the size of all your elements will change at certain points. And then it's not a good idea to have this 90 pixels here hard-coded right there in the code. Let's just take a look so we see what we actually need to get. So this is the rectangle. And so here we actually have a height property. So this is where that 90 comes from. So let's read that directly here. Height. All right. And so now here we can use that. Let's create a nice template string here. Nav height. And with that, I believe we're actually done. All right. And of course, this works no matter how large or how small the viewport is. Okay, now it works beautifully and correctly in all situations, and this is a lot more performant and a lot better than the solution that I showed you in the previous lecture. So play around with this, but we will actually also have, I think, 2 more examples with the Intersection Observer API coming up. And so that's going to be another great opportunity to learn how this API really works. Because it's quite important actually to do things on certain positions on the page. So things related to scrolling. Let's implement another really cool and modern feature using the Intersection Observer API. And this time we're going to reveal elements as we scroll close to them. And this effect can give your pages a very nice touch, and you can in fact easily implement it without any external library. So the effect that I mean is this one here with the sections. So watch what happens here. So you see that we basically reveal each section as we approach it. All right. So I'm not talking about these images here yet. So I'm just talking about the sections. So see how it basically slides in like this. All right. And so that's what we're going to do now with all these 4 sections. Now the animation itself actually comes from CSS. And so once more, we will actually achieve this by simply adding a class to each of these sections as we approach them. And so we will do that using the Intersection Observer API once again, because that's really the perfect job for this tool. Okay, so let's actually take a look at our CSS here. So I'm going to write or to search for a section hidden. So this is the class here. And so basically all the sections by default have this class. So let me show that to you also. Well, actually they don't. And of course they don't, because then we could not see them right now. Okay, so we have to add them now as we build this. And so this will basically give them an opacity of 0, and it will move them a little bit down. And so then when we remove this here, it will then move them back up to a translate of 0 rem, basically. Okay, so what I'm going to do is to start by adding this section, or this class actually, to all the 4 sections that we want to apply this effect to. So this one here, then the next one, number 3, and number 4. Yeah. And so now all of them will disappear. Okay, they're simply invisible. They're still there, so we are still like displaying them, and so they preserve their height, basically, but they're now invisible. And so our job is now to remove this class as we approach each of these sections. So reveal sections. So let's say a section observer, new intersection observer, and then here the callback, and let's already create it here. Let's call it reveal section, like this. Entries, and this time we will need the observer, and you will see in a minute why that is. So observer, and of course these parameters here, as always, can have any name that we want, right? So just like in the callback functions of the array methods, where we can also give them any name, and here it's the same, but this is kind of the standard, and so that's why I keep doing it like this. So reveal section, and then the object of options. So we want to observe all the 4 sections actually in this case. And it is indeed possible to observe them all using the same observer. So let's select all the sections, and then we will observe these as multiple targets, all using this observer that we just created here. So all sections is document.querySelector all. And so that's simply the class section. And now we can loop over this node list with for each. So we use for each whenever we want to do something which does not involve creating a new array. And so here the callback function, I will call it section. And then just like before, we will use our observer to observe section. And actually, since we're already looping over all these sections, it would probably be a better idea to add this class here, so this section hidden, also using JavaScript. So not do it manually here in the HTML, and instead do it in JavaScript. Because some people actually disable JavaScript in their browser, and then for those users, the page wouldn't really be visible, right? They would then have no way of removing this class. And so this is probably not a good idea. So I will copy it now, and then I will just undo everything we did. So yeah, so now it should be back to normal, and it is. And now I will do that programmatically here. So that's a lot better. Don't know why I didn't think of that right away. So class list add, and so this is nothing new at this point. Let's see. And now they are back to being hidden. So let's start by taking care here of these options. And as always, the root is going to be the viewport, so null, and then the threshold. We will set it to something greater than 0. And that's because we don't want to show the section right as it enters the viewport, but a little bit later. So let's say 15%, for example, for now. So this will make it so that the section is only revealed when it is 15% visible. All right. So this is all of the setup. And now let's create basically the logic. So in here. And once again, we have only one threshold. And so let's get that entry from the entries using destructuring. And as always, let's start by logging the entry here. Give us some more space. This 90 is coming from up here, so we don't need that anymore. Okay, and so now we see that some section here is already being intersected at 0%. And so now actually this target element will become important. And well, right now there is no target because this first, so to say, event is always triggered no matter what. So let's scroll a little bit until 15% of the first row is intersected. And of course, that intersection happens even though we cannot see it. So we don't see the row, but still it is now 15% intersecting. And now the target here is actually important. And so here we actually have the class name. So section and section hidden. And so this means that actually a certain section did now intersect the viewport. Maybe we can see the ID. Oh yeah, here it is. So it was the section 1 indeed. So the one with the ID of 1. And this target will now actually be important, because now we want to make exactly this section visible, not all of the sections, right? But we are observing all of the sections here with this same observer here, right? And so now we need a way of knowing which is the section that actually intersected the viewport. And so that's what we can use the target for. And so let's do that. So that's at entry.target. And now we can, as always, manipulate that class list and remove this section or this class that hides it. And you see that it's already working. Well, it actually happens a bit too soon, it appears. But on this one, it was perfect. Let's see the next one. And again, it worked just fine. And the last one as well. Let's try again this one here. And for some reason, it's already there. And I guess the reason for that is this first entry here that always gets printed in the beginning. So yeah, you see that the target here is actually this first section. Now it is not intersecting, and so let's now use that to our advantage. So we only want to trigger this removing here when the section, so when the target is actually intersecting. So if entry.is intersecting, then do this. And actually, I'm going to use another guard clause here. So I will do the opposite. So I say, if it's not intersecting, then return right away. Okay? But if it is intersecting, then the function will not return, and simply the rest of our code is going to be executed. So let's try that one more time. And now you see it's not yet visible, but it will become visible soon. And there it is. Beautiful, and it still works. All right. So that's a really nice effect, right? We can just do one more small improvement, which is to now unobserve these sections. Because you see, as we keep scrolling, the observer keeps observing the sections. So you see, as we keep scrolling here, more and more of these events keep getting added. But in fact, they are actually no longer necessary because we already did all the work that we wanted. And so we can now unobserve. And so that is again by doing observer.unobserve, so the opposite of observe. And then again, we need to pass in which element should be unobserved. And so in this case, that comes from entry.target. So let's see what happens now. So the first time, of course, we get these logs here because, of course, work is being done. But right after that, each of these sections is being unobserved. So let's go to the end here. And when we clear this now and keep scrolling, you see that we get no more events here. And so that means that none of these sections is being observed anymore. And so that's going to be even a little bit better for our performance. All right, and that's actually it. So another really cool use case of the Intersection Observer API. One of the most important things when building any website is performance. And images have, by far, the biggest impact on page loading. And so it's very important that images are optimized on any page. And for that, we can use a strategy called lazy loading images. So let me show you now how to implement that strategy in JavaScript. And the effect that I'm talking about is this one. So watch for what happens with the images in this section here. So you see, as we approach it, it basically starts to load, and then once it's finished, it will get displayed, and that placeholder, which is there in the beginning, gets replaced. So you see that? So let me quickly show you in the HTML how we implement that. Oh, and we're actually already here. So it's these features here, and so each of these features has an image. So the main ingredient to this lazy loading strategy is that we have a very low resolution image, which is really small and which is loaded right in the beginning. So that's this image here. And you see that the dimensions are only 200 times 120 in this case. So let's actually take a look at that image here. And so you see it's really small and it's only 16 kilobytes, while the real one, so this one called digital, is almost half a megabyte. So that's a huge, huge difference. And that image we then reference here in this data source attribute. So that's a special attribute that we can use, but any other would work as well. So this is not a standard HTML attribute, but instead it's one of these special data attributes that we can do ourselves. Okay? And so basically the idea is to, as we scroll to one of these low resolution images, we will then replace this low resolution image with the one that is here specified in the data source attribute. And we then also are going to remove this class here, which is kind of this filter which makes this image blurred. Because without this filter, let me show that to you. Without this, it would look really terrible. So, too small to change this now here. Okay, but let's just remove it here for a second, just so you can see what it looks like. And so maybe you can see, or maybe it's too small, but notice that it's like really pixelated and really ugly. Okay, and so I created this filter basically, and so it makes it look like this. So it hides the fact that it is actually way too small for its size. All right, so let's put it back here. And so this is what this class looks like. It's simply a blur filter. And so modern CSS allows us to do this really cool effect. Okay, so let's implement this, and that's actually not too hard, using the intersection observer API one more time. So lazy loading images. And so once again, this one is really great for performance, while the other things we did so far are more visual things. This one really impacts how your site works, and especially for your users who might have a slow internet connection or a low data plan or a slow cell phone. And we always have to think about these users as well. Not everyone has a super high-end computer or the latest phone. All right? Anyway, let's start by selecting our images. So let's call them image targets. And this selector is going to be a little bit different this time, because we don't want to select all the images. So we could simply do a selector of image, and that would then give us all the images. But however, not all of them are going to be lazy loaded. For example, this one here, or we have some down here somewhere. Yeah, so these avatars here, or even this logo. So these are not lazy loaded. And so the ones that will be lazy loaded are the ones that have this attribute here. So this data source attribute, because that's where we specify the real high resolution picture. And so we can actually select for elements which contain this property. So if you're familiar with CSS, maybe you know how to do that. But in case you're not, this is how it works. So we select all the images which have the property of data source. Okay, and that's it. So let's check that just to be sure so that it's going to work. And so indeed, here we have these 3 images. Okay, and nothing else. Then let's create our image observer. And so this is now always the same. Here our callback function, which I'm going to call load image in a second, and then our options. And now let's attach this image observer here basically to all these targets. Okay, so I'm going to loop one more time over our targets, just like we did with the section previously. And this time let's actually use an arrow function, because all we want to do is to use the image observer that we created previously to observe each image. Now let's create that callback function here also pretty fast. So it gets the entries and also the observer. Now, okay, as always, starting with the options here, and again the root set to the entire viewport. And let's start with the threshold at 0. And then we can adjust it as we go. But what matters really here is this callback function. So as always, this is where our functionality is. And so again, we have only one threshold, so only one entry. So I'm getting that here. And now let's check out actually this entry. Okay, so here we already got 3 of them, but all of them are not yet intersecting. Or actually it says that this one is. Well, but it isn't really, because it's down here. So that's a bit weird. Oh, but of course, this still comes from the sections. So this is still coming from up here somewhere. Okay, let's delete it here from the sections. And now let's see if it's working. And now it is indeed an image. Okay, now it appeared a little bit before, and that's because remember that our sections are actually a little bit shifted, right? Because of these hidden class that we added to them, they are shifted 8 rem down. So remember that from here. Let's see. Yeah. So because of this translate here, they are moved 8 rem down. And so then therefore this event will fire a little bit early, but that's not a problem at all. All right. What matters is that the event fired correctly and that it is indeed intersecting. Let's just clear it here to wait for the next ones. And so here you get the next one already. And so that is indeed this next lazy image here. And then the next one here as well. Oh, so this one. Okay. And then as we're moving out of them, then we get even more, because now they're no longer intersecting. And so once again, we need to only do something if they are actually intersecting. So we're going to use the same guard clause as before. So if they're not intersecting, is intersecting, then we want an early return. But otherwise, we now want to replace the source attribute with the data.source, right? So as we reach the image, it's finally time to replace the placeholder image, which is at the source, with the one we actually want, which is data source. So just like before, each of these images here is at target, or actually at entry dot target. So that's the element that's currently being intersected. And then dot source equals entry dot target dot dataset Remember, that's where these special data properties are stored, and then dot source from there. Okay, so this is already the main functionality right here. So let's try that. But you will not really see it happening because there's still this blurry filter here on top. But if we inspect this now, we should already see that the source is now actually already the original image. So you see that it's the really big one, while the other ones are still the lazy ones. Well, at least this one. The second one is already also the original one, because it's already in the viewport too. All right. So that's great. That's working just fine. Now all we need to do is to then remove that class that has this blurred filter. So that's the lazy image class. Now, how do we do that? Well, it's a little bit tricky because this replacing of the source attribute actually basically happens behind the scenes. So JavaScript finds the new image that it should load and display here, and it does that behind the scenes. And once it's finished loading that image, it will emit the load event. And the load event is just like any other event. And so we can just listen for it and then do something. So on that image, so that's entry.target, we can do add event listener and listen for the load event. Okay. And actually, let me show you why it is important that we do this. So let's say that we removed that lazy image class right away. So entry.target.classlist.remove lazy image. Let's scroll up here, reload. And then, well, in this case, the loading happens so fast that we don't even see a problem. Maybe we can change that here in the network tab. So this is a completely new tab, but what we can do here is to simulate or speed. So this is a bit too big here actually, I guess. So I'm not used to this size. Let me make it a little bit smaller. So let's change it here to fast or to slow 3G. And maybe then we can see what happens. So it's now faking that these images are loading really slow. So did you see them here blurred now? So it's really blurred. You see? But we already removed the filter. And so here you can see how the image is loading basically in the background. And so it's doing that really slow now because we said that we are on a slow network here. And now you see it's finished here, and now the original image is being displayed. So hopefully you could see that. I'm not sure if the resolution of the video is going to be good enough to see it, but I did for sure see it. And here actually now the same is happening. Let me increase the size of the window a bit maybe. So you see it's pretty blurred, but once it's going to be finished, you will then see the final and beautiful version showing up here. All right. So we're going to come back to this network tab later when we start loading data from remote sources on the internet. So this is a very important tab in the browser tools. But for now, it's also nice to see the images loading over time behind the scenes. Well, it's taking a lot of time. So let me just go back to the code here. And so, yeah, now it's finished actually. And so by the time this loading finishes, it will emit this load event. And so it is best to then only remove that blurry filter once that is done. All right. So it's loading again, very slow now. And you see that now it keeps being blurred and it will only disappear once the image is in fact loaded. So I'm not going to wait for that because it seems like it's going to take forever. Oh, actually it's already done here. And so you see now the image is downloading and at the same time the filter appeared, or actually disappeared. Let's set it back to online. And so now all of it happens basically at the same time because we are working on our local development machine. And so there, of course, the image basically arrives instantaneously. Now, as a last step, we can just, as we did before, stop observing these images because it's no longer necessary. We already did our task of loading, and so we no longer need this. So entry.target, and that's it. So I hope that with this video, I could convince you that it's really important to implement this kind of functionality into your own sites. So all you really need to do is to generate these placeholder images and blur them a little bit, and then implement this kind of logic, which really shouldn't be too much work, right? Let me just get rid of this console.log here. Let's load it again, because actually we want probably to load the images a little bit before we actually reach them. So ideally, we don't want our users to notice that we are lazy loading these images, right? So all of this should basically happen in the background without our user noticing that. And so we should probably make these images load a little bit earlier. So to do that, we can again specify a negative root margin here. So root margin of, let's say, minus 200 pixels. All right. And so this is just the same as we did previously here with the navigation. So to make the navigation load a little bit before the threshold was actually reached. And here we are doing the same. So exactly 200 pixels before any of the images is loaded, it should already start loading. And by doing that, we don't see any delay in loading when we browse the page. Well, actually that didn't quite work. Maybe it should be plus 200. So as you see, this is all a matter of trying out and figuring out as we go here. And so now indeed, as we approach the images, they're already fully loaded. So now that happens 200 pixels before we reach them. All right. And with that, our functionality here is complete. And we are now indeed almost finished with this project. All that's left to implement is really this slider. So this component here. And so that is what we're going to do in the next video.